as we continue studying about basics of operating system. In this lecture, we'll be studying about storage structure. So as we study storage structure, we will be seeing different storage devices that we have in our compared systems, and we will see what are their functions and what are their features. So here we have a diagram given, and in this diagram, it represents the storage device hierarchy. So on the top, we have our registers, followed by cache. Then we have the main memory. Then we have electronic disk. Then we have magnetic disk, and then optical disk, and then magnetic tapes. So if you look at these devices, starting from registers, they are the smallest storage devices, and they store data in bits that mention zeros or ones. So they are the smallest devices. And then since they are the smallest and they store only bits, so they can be accessed very quickly. And then the next one is the cache. The size of the cache is a little bigger than that of the registers, but its speed is a little slower as compared to the registers. And then after that, we have our main memory, which is the very important thing that you need to know. Examples of main memory: audio random access memory, audio RAM, which I will be discussing in detail. And then we have electronic disk, magnetic disk, optical disk, and magnetic tapes. So these are the secondary storage devices. So I shall be explaining you what are main memory and what are the secondary storage devices as we proceed further. So if we look at this hierarchy, when you go up to the hierarchy, it becomes expensive. They are expensive, but they are fast. Okay, and then the size also becomes smaller as you go up the hierarchy. So this is the biggest size. And if you go up to this, the size of the devices becomes smaller and smaller, but then their access time and cost, it becomes higher and higher as we go up the hierarchy. So we can say that registers are the smallest in size, but their access time is the fastest. And as you go down the hierarchy, the cost per bit increases, and then the access time also increases, and their size also increases. So we can see that if you want small size and fast access, then this is where you have to go. And if you want bigger size for storing more data, then you have to go down this hierarchy, coming to this electronic disk, magnetic disk, optical disk, and magnetic tapes. And here the cost and access time increases. Now as we talk about this, we have a talk about our main memory. This is the most important thing that we need to talk about. So main memory is your RAM, or the random access memory. And what is a function of main memory? In the main memory, anything that you load in your computer gets loaded to your main memory, and that is where it is executed. So things are stored in your secondary memory, but things are loaded to your main memory for the execution purpose. Now, what do we mean by secondary memory? This main memory, it is fast, but its size is limited. And also, it is volatile in nature. And I will explain you what is the meaning of volatile. But remember that the size of this main memory is small, so you cannot store all your programs and data into the main memory. So for that purpose, we have our secondary memory. So in our secondary memory, we can store all our data and all other things that we need. And when it has to be loaded or executed, it is loaded into the main memory and get executed. So for example, let's say that you have your word processing software. That is your Microsoft Word. So if you have your Microsoft Word, it is installed in your secondary memory. It stays or resides in your secondary memory. But when you double-click and open it, then it gets loaded to the main memory, because you are going to perform some task in that Microsoft Word. So whenever you execute something, it gets loaded in the main memory. Otherwise, it is reciting in the secondary memory. So all your data is research in the secondary memory, and it's loaded to the main memory. At the time of execution, no. We say that when you have a larger or a bigger RAM, then your computer works faster. You must have heard this many times. Now why is that? Why do you say that? When you have more of random access memory or RAM, your computer is faster. So remember that. Main memory is your RAM. Your RAM is the main memory. So for explaining this, let me take a simple example. Imagine that you are in a room, in your study room, and then you have a bookshelf. You have a big bookshelf where you can store many books. And then on that bookshelf, you are having lots of books. And then beside you, there is a table. There is a small table on which you keep your books for reading. Now think of the bookshelf as your secondary memory and the books as your data. So all the data, that is your books, are kept on the bookshelf. But when you want to read a book, what do? You take out the book from the bookshelf and you keep it on the table. And then you read it. So just assume that you only read your book on the table. You don't like to read it in other ways. So whenever you want to read, you take a book from the bookshelf and you keep it on the table. And then you read it. And consider that table to be your main memory or your RAM. Now let's say that your table is very small. So if your table is very small, what happens? Let's say that you can keep only one book at a time in your table. So if you can keep only one book at a time, so you cannot use more than one book for studying. Even if you want to refer to 3 books for studying, you cannot, because you can only accommodate one book on your table. No matter how big your shelf is, the number of books that you can study at a time depends upon the size of your table. So the table, you consider it as your main memory. So in the same way, even if you have a large secondary memory, when you load things, it is loaded into your main memory. So if you have a bigger main memory, then you can load multiple things and your computer will work faster. And if you have a smaller main memory, then the things will be loaded in a slower way. In a computer will be slower. So that is why you usually hear that when you have more RAM, your computer audio system performs faster. Now, as I was explaining to you, I said that main memory is volatile as compared to secondary memory, which is non-volatile. Now let us try to understand the meaning of volatile and non-volatile. So volatile means that it loses its contents when the power is removed. So all these devices like your main memory, cache, and your registers, they are volatile in nature, which means that when the power to these devices are switched off, then whatever was stored in these devices will be removed or erased. All right, and on the other hand, the secondary memory that you have, they are non-volatile, which means that it retains its contents even when the power is removed. So even if you switch off the power to these non-volatile devices, their contents will not get erased. They will be retained even when the power supply is removed. So here registers, cache, and main memory, they are volatile, whereas electronic disk, magnetic disk, optical disk, and magnetic tapes, which basically are secondary storage devices, the unknown volatile. This electronic disk sometimes it can be made to be volatile, as well as non-volatile. And even your main memory, your RAM, there are different kinds of RAM that you have. And there is also a known volatile RAM called NVRAM, which has a battery backup in order to retain its contents even when the power is removed. So those are some special cases, but otherwise basically this registers, cache, and main memory are volatile, whereas the other devices, the secondary storage devices, are non-volatile. So once more, let me tell you what is the meaning of volatile. So in volatile, when the power supply is there, then this devices will retain their data or its contents. But when the power is removed, or when the power supply is gone, then whatever contents or data that was there in this volatile devices will be removed or erased when the power is gone. So in non-volatile, whether the power is there or not, its contents are always retained. So in volatile devices, only when the power is there, its contents will be retained. Otherwise, it will be removed. So these are some of the things that you should be knowing about story structure and storage devices, which are also basic software operating systems. So we understood the hierarchy, and we understood what is main memory and what is secondary memory, and we also understood the nature and their features. So I hope this was clear to you. Thank you for watching, and see you in the next one.